Today I'm participating in Codechef. Started around 2:36. Want to start it. The first problem. So a string whose length is odd is said to be cute if every character at odd index from the beginning is either the character U or O, and every character at even index is the letter W. For example, U, W, U, all the characters are cute. You are given a string of length containing only lowercase English letters. Find the length of the longest contiguous substring of S that is cute. So length is only 100. So we'll just try all possible ways, right? We can just try all possible ways. Given n. So for example, len is equal, we can try for n, len n, len less than is equal to 1, minus minus len. All of the character lowercase Latin letter. Okay. So take the string S. Then if we start from I, this is the range, like L is equal I, R is equal I plus len minus 1. So we try from K is equal L to K less than is equal R, K plus plus. We keep a boolean variable like it's okay. So if K mod 2 equal 1, if S of I, S of K is not equal, it's an even index, so it must be W. If it is not equal to W, then OK is equal to false, and we'll break. Else, if S of K is not equal U and S of K is not equal O, then also K is equal to false, break. If OK true, then we'll just output this len. Otherwise, probably len is equal to 0. Let's see. No, wrong answer. First test case is working. For the second test case, it's not working, but it looks like the yeah, it's wrong. Right, not K mod 2, it's like L R it's the first index, so K minus L, K minus L plus 1, or if we use 0 base indexing, then this is the odd index. Now it's working. Yeah. No. For the last test case, WO. Yeah, W should be valid substring. The substring 0 at index 4 is the longest Q substring. Every character at odd index is either the letter U or the letter 0. So for this test case, the odd index is the first index. It's either U or O, so it's okay. Then the second even index, the should be W. You are given a string S, find the longest contiguous substring of S that is cute. So why it's not 2? What am I missing? Alright. This is the second index. Right. And it's the first index. Start from 1, this is the first index. Then this is also the first index, this is the second index. If it is 3, this is the length, the starting position. Then W, OW, then UU. I'm still confused. Character at odd index from the beginning. The character at even index from the beginning. Oh, sorry, length should be odd. What the? Length should be odd. Shit, that was so silly. This is the second problem. So, on index array P of length n is called a palindrome. If Pi is equal Pm plus a hold for all integers, for example, is this. Chief loves palindrome. Chief also loves the number k. Chief has him an array A of length n. He can repeatedly modify the array as follows. Insert an occurrence of k anywhere into the array. In particular, it's allowed to insert before the first element or after the last element. It is possible. Is it possible for Ceph to perform this modification several times so that the resulting array is a palindrome? We are given n and k. So Ceph can insert the number 3 anywhere. So you can insert it here to make it palindrome. And I think it's only depend on the frequency. Yeah, I think it's only depend on frequency. If the current elements can be reordered to make a palindrome, then I think it's possible. For example, why the third case is no? 2, 2, 1, and 4, 4. 1, 1 is here. 2, 2 is here. Yes, 2, 2, 3. Like for the test case, 1, 4, 2, 1, 4, 2. So if we insert 2, 3 here, then what is happening? 4, 4 came in the first position. Oh, I think the order should be maintained. 3, 3. 1, 1, 2. I think all the elements except k in the array, their order should be a palindrome. Right? Their order must be palindrome. Like for example, 1, 2, 2, 1. But there are some, let's say 5, and here is also some 5. So you can insert this 5 anywhere. But there, if the order of the element, like 1, 2, then we can never make it palindrome inserting 5, no matter how many times we do this operation. So I think the solution goes as follows. N k, then we take a vector but we'll only insert those elements like if x is not is equal to k, then a dot push back x. Now we just check if this is a palindrome. Bool k is equal to 0, j is equal to dot size minus 1, j is greater than I, minus j plus I. If a of I is not is equal to a of j, then okay is equal to false. Break. I think I should use int here because the array A can be empty. Cout yes, otherwise no. Okay, let's submit. Okay, so our idea was correct. Then the next problem, shift and sort. You are given an array A of length n. You can modify it by the following operation. Choose an integer k with non-negative integer, and then choose k indices such that the index I start from 1 or greater, and the adjacent index okay, a of ij of ij minus 1 must be greater than 1. That means there is no adjacent index for each of them, and last index cannot be the cannot be in the operation. Choose k positive integer. Finally, for each j, subtract xj from aij, and add this to the next element. aij, add xj to aij plus 1. In simpler language, you can choose several non-adjacent elements of the array and then transfer some positive value for each chosen index to its immediate right. Using the given number of using the given operation at once, it is possible to sort the array. Is it possible to sort the array in non-decreasing order? We can do this operation only once. So we can just shift some value from particular index to the next index. But after shifting those values into the next index, that value we cannot shift after that index. 2, 5, 8, 9. This array is already sorted, then 3 to 1 is not possible. Clearly it is not possible. 4 to 5, 7, 10, 7. It is possible. Since 4 is greater than 2, we must select 4. So you need to we will transfer the minimum possible value. In that case, we will just transfer 2, and 5, 7 is fine. 10, 7 will shift at least 3. Then 1, 3, 3, 2. It's not possible. Can we do it greedily? Like for an element, if ai is greater than a of I plus 1, then we need to transfer maximum of a of I plus 1 minus a of I, comma and to transfer I mean we must transfer this amount a of I plus 1 minus a of I, but we also think about like the previous element. There is a minimum bound that how much we can transfer, but is it matter? Does it matter? I don't think it is matter, because this is the minimum possible amount that we must need to transfer into the next element from ai. So there is also a minimum bound that we can transfer from ai, so that the previous element of ai will stay lesser than ai. That is, the minimum bound is a of I minus a of I minus 1, I think. Yeah, that how much ai is greater than this element. Now if the minimum bound, like if this minimum bound of the minimum bound is smaller than the minimum amount we must transfer, then we need to think about like the previous elements from where we can take some value into a of I minus 1 so that our minimum bound increase. It's only possible. Then again comes the other part, like the minimum bound we need to transfer. So can we go from right to left to just greedily check like how much we need to transfer, whether we can do it or not? Based on that, the electricity gone, the Wi-Fi will gone as well, but anyway, we don't need the Wi-Fi right now. We only need that when we will submit. So like if we go from right to left, okay, it's back, then we can greedily like have how many, what is the minimum amount of value we need to transfer. Every time taking input of an array, like declaring the vector and iterating over the loop, writing the same thing again and again, kind of boring. Probably I should make some shortcut. Yeah, why not? Same redundancy, just writing same thing. Yeah, I think I should make a shortcut. Okay, so we'll go from left to right. We'll start from n minus 2. Why? This is because we cannot do operation in n minus 1 index, like the last index. So if a of I is greater than a of I plus 1, then we need to do some operation, like the val. So it will become like a of I plus 1 plus is equal we can do this. Val is equal to a of I plus 1 minus a of I. So a of I minus is equal to val, a of I plus 1 plus equal val. And we'll do this. Why we are subtracting minus 1? This is because we have already did an operation in this ith index, so we cannot do the operation in I minus 1 index. So later we check if is sorted. Then it's yes, probably this, otherwise no. I am not sure about the solution of this problem, so yes, that's why this is wrong in the third test case. What is the final condition of the array? Why it is 4? Oh, sorry. It will be a of I minus a of I plus 1. Okay, yes, it's giving correct answer. So our logic is like, we know what is the minimum amount of value we need to transfer from that particular index to the next index. So we have to do, there is no other way to make it non-decreasing. So let's say we just did that, and we skip the last element because we cannot do the operation of that particular index since we have already done in this index. Then the same thing, right? Yeah, I think it will work. I think like it will work. Let's see. Failed. Wow. Can do this operation at plus 1. You can modify it by the given operation, choose an index I, where k is greater than or equal to 0, then choose k indices I1 to ik, which are increasing. I1 can be 1, but I of k cannot be n, and their difference cannot be greater than 1. So then we will choose k positive integer. Positive integer, right? So we'll only do operation if it's strictly greater, so it will always be positive. Then for each j, subtract x of z from the of ij and add this to the next element. In that similar language, you can choose several non-adjacent elements of the array and transfer some positive value from each chosen index to its immediate right. Using the given operation at most once, it is possible. Is it possible to sort the array in non-decreasing order? I think I clearly understand the problem statement, so there is no problem on understanding. Okay, just select some non-adjacent element and transfer some value. So why it's giving wrong? Can we make a test case for which this will give a wrong answer? What we are doing, let's just try to visualize. We are just trying to transfer elements. By doing this operation, what happening is that this element is decreasing So we need to do some increasing in the if this element increase decrease, then we cannot do. There is no way to increase this value, increase this element, I think. Right? Once we decrease a particular element by doing some operation on that index, I think there is no way to increase that value. Since we cannot do the operation in the immediately previous element. Are we doing it correctly? And minus 2. Let's try some test case like 3 1 3 2. It will definitely work since it's 2 element. Then let's say 4 5 3. No. Why? Because we are doing operation in the second index, and then we cannot increase this value again. Three, 4, 5, 6. In the third test case, they are choosing on 3 5. And what is our final LA for the third index? What is our final LA for the third index? 2 4 5 7 7 10. But here their final array is 2 4 4 8 8 9. How? They chose on 3 5 and the value is 2 1 2. So 1 3 5 2. So obvious it must need to transfer the value 2 into the next element, the second element from the first element. So 2 4 is correct. Then how the next element is 5 in our and how there is 4? Oh. And they did operation on the third index, decrease it by 1 and increase it by 1. Is it necessary? My question is it necessary? I think there are two options. To do it from the beginning and from the end as well. So if I k of I is if I equal to 0, then we can do operation on that index, or we don't do operation. if we do some operation, wow, what a confusion. So they did operation on the third index, which is optimal actually, because it is transferring some element. Transferring 1 into this index, and then he is just transferring 2. Hey, shit, I did a mistake. It's not like that. We just need to add the value, like shit, val plus 1 divided by 2 and val by 2, I think, or not. What is the difference from this index to the next index? Is this. Three, 8, 9. That's correct. Difference is 3, so we'll do at least need to transfer 2. So we did that. Then 7, 8, 5, 7 is fine. Then 2, 3, we need to just transform. I think this time it will work. We just earlier let's transfer more element, which is not, this is unnecessary. Yeah, shit, that was a silly mistake. Minimize distance. Distinct. You are given an array of length n such that all of these elements are between 1 and n. For a spare LR such that valid range from that array, we define the array f of LR as follows. Consider an array B of length n for its index I from set bi to ai of I plus 1. Otherwise, set bi to I minus 1. We define f of LR is equal to b. For example, this, then 2, 4. For 2 and 4, I see. All of the values are from 2 to 4 will get increased, otherwise they will get decreased. Let's distinct b denote the number of distinct elements present in the array. For each L from 1 to n, solve the following operation. Compute the minimum value of distinct f of LR across all possible choice R. Oh. So from all possible L, all possible starting value, we need to choose some element. So it does, order doesn't matter. Order doesn't matter. We'll definitely sort the elements. So for the first disk is 1, 3, 1, 3, 2, 4, and for L is equal 1, what is the optimal R? R can be from 1 to n. So if it is like 1, it will increase to 2, and it will become 1, it will become 2, it will become 4. So we'll sort like 1, 2, 3, 4. So if R is equal 1, then the array goes like 2, 1, 2, 3. So it's 3. The answer is 3 for the L is equal 1. Where it's 2? All the elements inside that range we will increase, other we will decrease. So for 1, 2, 3, 4, from 1 to 1 we increase this value, otherwise we decreased. So now there are 3 distinct elements. Oh, sorry, it's minimum distinct value. So we need to minimize, not maximize. For L is equal to, for R is equal to, if we increase the first 2, it will become 2, 3, and it will also decrease to 2, 3. Some element increase, some element decrease. If we increase the range, what happened? Like there are some element A1, A2, A3, and there are some other element which we will decrease. These are A4, A5, A6. And after the decrease operation, A3 minus 1, and A4 plus 1, A5 plus 1, A6 plus 1. Oh, sorry, I just did the reverse. So they are greater value like this. So what can happen, like these 2 elements, like for example, if it is 1, 2, 3 and 4, 5, 6, now increasing on to 3, 3 can become 4 and 4 can become 3 and 2 will become 3. So this 4 is basically pairing with 2, because 2 will increase, 4 will decrease. So the frequency of 2 and 4 will not frequency, actually they just decrease the distinct element by 1. 2, 3, 4, 4. 4, 3. I think I again misunderstood or misobserved basically, because from L to R, not necessarily that this index will be always small. This can be greater. Like for example, for this case 1, 2, 3, 4, when we select L to R from 3 to 4, then we will basically increase this element. In that case, the frequency, the distinct element count never change when L is equal L greater than greater than I think distinct element count had decreased by 2. Why? Because of this element combined with this, and this element combined with this element. So basically the distinct element count can only be decreased by at most 2. When it will be decreased by at most 2? When we have this consecutive 4 elements which basically exist in the array. If we do not have that consecutive 4 element, then we cannot decrease this the distinct elements counts by 2. Then we probably try to decrease the distinct count by 1. In that case, we will try to find out a pair of this, like a of 3 and a of 5. This is exactly, let's just ignore one a. It's like 1, 2, 3, 4, 4, 5, 6, 7. So if we have 3 and 5, so 3 will be increased by 1, 5 will be decreased by 1. So they'll just match. And same thing for 2 as well. So yeah, we can do something like this. Save these elements. Sort all A, and we can think like we have this or not. Like has of A of I is equal 1. We have has this. Now we can just maintain a F array which will tell us what is the maximum if has of I, then f of I equal f of I plus 1 plus 1, right? What is the maximum consecutive element we can mass? And we will do suffix maximum of this f array. So f of I will be max of f of I comma f of I plus 1. Maximum consecutive elements we have. Then we will check for the crisscross count, if we have A3 and A5 or A2 or A4. For that we can maintain another array, maybe let's say Z array. So let's start from the I is equal to n minus 2 this time, because if has of I and has of I plus 2, I think, yeah, then Z of I is equal to 1, right? And Z of I plus 1. So we'll try for all the L from 1 to L up to n. If f of L is greater than or is equal to 4, then just maintain distinct element. Number of distinct, dist st dot size, then cout dist plus 1, sorry, dist minus 2. Else if g of L, if it is true, then cout dist minus 1. Else, if we do not have any of them, then probably we cannot decrease the distinct element count, so this will be dist plus 1, sorry, not plus 1. This is not I, this is L. Two, 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 two. So debug F for the first array. What? What is this? Has of n. Because of this. If I plus 1 less than or equal n. So f of I is at least 1. 2, 3, 4, 4. This time it looks like it's working for the first case. 3, 3, 4, 4. I'll submit. Yeah, it's correct. Idea of this problem was cool, I must say. All aside, you are given a binary string s of length n. You can perform the following operation on it. Choose an index I, let LR be the maximum segment of equal elements containing index I. Okay, more formally, they are equal. Flip the values at index L plus 1, pi minus 1, I plus 1, try. Let L, R be the maximal segment of equal values containing index I. More formally, L is the smallest index such that SL plus 1 R is the largest index such that especially every index in range ultra except for I has its value flipped. Be the maximal segment of equal values containing index I. More formally, L is the smallest index. Oh, okay. So from a segment of equal values, we can choose a particular index I, and we will not flip that particular index except all the index except I will flip. You are allowed to perform the above operation however many times you like. Find the lexicographically smallest final substring that can be obtained. No, LR is fixed for a particular index. LR is the maximum segment of equal values containing index I. So for a particular I, L is kind of fixed. Okay, so in the binary string there's some segment. Okay, the binary string, they just give the definition of lexicographically smallest. This is a fixed index which is already lexicographically minimal. For this index, we'll definitely flip all the index from there to there except the last index. From here, we cannot do any operation. Why we cannot do any operation? Maximal segment of equal values containing index I. If we select one range, then this particular index will not be flipped by the definition of the operation. If we select this range, then we can flip all these 3 into 0 and this 1 into 1. Next, what they did, any operation performed the index won't change it at all, since an index I. They didn't give the definition of the third operation, third index, 0 0 1 1 1 1 0 1 1. They convert this binary string into 0 0 6 zeros 1 0 1. 1 0 1. They somehow convert this 0 and 1 into 0, which is possible. Then also, like, they somehow convert this 0 into 1. How? If we select this range, then we can select any I such that all of them will become 0 except that particular index. Okay. Then let's say we just keep this index 1 and others 0. This will be 0 0 1 0 0 1 1. Then we did operation here, so it will become 0 0 0 1 0 1 or 1 0. This is the same. Didn't understand yet. How they convert this string to that string. Basically, we need to just figure out how they convert this 0 into 1. What is the way? Just forget everything. We just need to somehow make this 0 into 1. So to do that, we need some adjacent 0. We got adjacent 0. So we'll fix this index. So this will become 0 and this will become 1 1 1. Right. So now this will become, we will make this 2 0. Okay. We are almost there. Now let's say we consider this range and I make this to 1 1, and after that we make this to 0 0. Wow. It is possible to do something like that. It's like we are just compressing from this 1 on. We can just compress from this 1 on. We are also compressing. Like we just make all of them 0. Then we make them also, let's say, zeros. 1, sorry, 0 1. Then from the 0 0 we make 0 0 1. Then 0 0 make 0 1 0 1. It's like we can take this 1 forward if there are multiple 0. If there are multiple 0, we can take this 1 into the like this structure 1 0 1. So what I understand from this test is like we have 0 0 0 and 1, then 0 0 0 1. Now we can take this 1 into here. This is my observation. Then this is very clear, like we have some segments of 1 this way. Then string of s, we will go from the first index to the last index if not exactly in the last index. If s of I equal 1 and s of I plus 1 equal 1, then we just do this. So, sorry, this will just flipped, right? After that, we have some segments of zeros and ones. Only one. The segment of 1 is only 1. Now we can shift the 1 right into the right. So if we try to do it from the left, like we can just store the position of 1 right now. So if s of I equal 1, then pos dot push back I, right? Then go through the last element. Second last probably, or no, not necessarily second last. It is second last because for the pruning we'll insert push back the end position. Now swap pos of, if it's only possible if the pos of I plus 1 minus pos of I, like the middle, how many zeros are in the middle. So if there are more than 1 0, so how many zeros are out there? If they are adjacent, then 1 2 3, so it have to be at least 2. Then we can swap s of pos of I comma s of pos of I plus 1 minus 2, right? Yeah. And pos of I will become now pos of I plus 1 minus 2. I think this is the lexicographically smallest possible string we can convert into. Yeah, it's working. So let's just submit it. Wow, it's worked. Nice contest going today. No, it's like 100 of people already solved, so it's nothing special. Valley avoidance. You are given a parameter k. A permutation p of n has a valley. If there exist indices, k indices such that max of this is mean of I2, I3 to ik plus 1, maximum of this is less than minimum of the border. So the okay, this is called valley. Like the border element are the greater element from the middle elements. There's the valley. That is, P has a valley if there exists a sequence of k indices such that the leftmost and rightmost element are both larger than all the middle elements. You're also given an array of length n such that all of them are from 0 to n for each index I. Further, the positive elements of A are pairwise distinct. Positive elements. So it's like a permutation where you are given an array A of length n such that all of them are from 0 to n for each index I. Further, the positive elements of A are pairwise distinct. A of I is greater than 0. Here they are saying greater than 0. Here they say it like less than equal 0. Here they say it less than equal 0, a particular element, and now they are saying this. Why? So let's go forward. Count the number of permutation P of n such that P of I is equal AI for all I such that AI is greater than or equal to 0 and P does not have any values. Answer can be used, so print the answer modulo. I am not clear with the problem statement yet. Like we are only given on integer, that is k. What the meaning of k? Like this is a parameter. So this parameter k says that the permutation P of k has a value if there exist k elements such that the border element are the largest among all the elements, like largest from the middle elements. So that is, P has a value if there exists a sequence of k indices such that the leftmost and rightmost element are both larger than all the middle elements. So the sequence of k elements not necessarily need to be adjacent. You are also given an array of length n such that all the values of AI are between 0 to n for each index I. Further, the positive elements of A are pairwise distinct. Positive elements, oh okay, except 0, all the elements which are positive, they are pairwise distinct. So if AI is not equal to A and I is not equal to J, then they definitely greater than 0. Okay, now this makes sense. Count the number of permutation P of length n such that P of I is equal to AI for all I such that AI is equal to 0. Like the initial value will be given. Now we need to replace those zeros, and P doesn't have any values. Number of permutation Pi is equal to AI and P does not have any values. The answer can be large, so pre-port it modulo 998244353. n and k up to 5000. So they are saying us to do something of complexity n cube. So you need to replace these zeros with the other elements. Like there are 4 factorial 24 possible permutation that can be found. Of them 3, 1, 2, 4 and 3 to 1, 4, like all the permutation we have 4 and 3 in the last, because k is equal 4, so the only possible sequence is the whole array. So now the border elements is the last and first element, so if they are equal the maximum element, then it's not possible. So other than this 4 array, the remaining 20 is a valid permutation. For test case 2, there are 3 factorial ways to fill the array 0, 3, 0 to form permutation, and all of them do not have any values with k is equal 4. There are 6 such a permutation. Like 3 is fixed. 3 is fixed here. So 0, 3, 0, 0. I need to put some values. Like what are the values we have? 1, 2, 4. So the only possible range is the whole array. So we there is 6 factorial, 3 factorial, so 3 into 2 into 6. In one side we can put 4, that's fine, but whatever we put in the other part, like here, will definitely be less than the element 3. So all such a permutation is a valid permutation where there will be no value of sequence 4, length 4. For the third test case, there are 2 ways only. Let's try to understand this test case. The only valid permutations are already given here, like 1, 4, 5, 3, 2. So whenever pick a sequence of 3 elements, border elements must be greater. So 4, 5, the maximum element 4 and 5, their distance between them cannot be greater or equal. Yeah, cannot be greater or equal k. Cannot be greater or equal k. I think in the permutation where there will be a value of length k, one of the side must contain the element n or n minus 1. One of the side must, right? Is it? No, I think it's not necessary condition. It's wrong. It's a false condition. Why this is false? Because there can be other element, like I could just put 3, 1, 2, 4. Then now let's say 4, 6, 7. all of them are adjacent, but there is a 4 length of sequence. This doesn't include 6, 7. That's not a valid condition. What is the necessary and sufficient condition to not to make any value of size k? I think this is a combinatorics type problem. Fifteen people solved it. I also want to read the last problem because it feels like the difficulty is almost similar. So you're given an array B of length n, you have an array A of length 2n. Initially ai is equal to 0 for all I. Using the array B, you will modify the array A as follows. For each I from on to n in order, do the following. First, choose an index j such that aj is less than or equal to bi. Using the array B, you also have a always exists. Then increment aj by 1. You are not allowed to skip any operations. So we'll do n operations. The total number of increments made in a must be equal to exactly n. Define f of b to be the maximum possible value of mix of a. Under an optimal sequence of increment operation, you are allowed to rearrange the elements of b however you want. Given an integer k, your task is to find rearrangement r of b such that f of r is equal to k. If there are multiple such a rearrangement, you may find any of them. If no such a rearrangement, print -1. So I have to rearrange the array A in such a way. Okay, I want to read the problem statement again. Here given an array B of length n, you also have an array A of length 2n. Initially ai is equal to 0. All the AIs are is equal to 0. Using the array B, you will modify the array A as follows. For each I from on to n in order, do the following. Choose an index j such that is less than or equal to bi. Such an index will always exist. How? What is the guarantee? Why? How they are giving the guarantee that such an index will always exist? First line will to a space separate integer n k the length of the array size in a space b of I. How they are guaranteeing? All the bi's are from on to n. So for I from n to n, we will choose an index j which is less than or equal oh, that's true. And bi can be equal to 0. So if all of them are 0, that's why they are granting, like there will be always a way, always possible, like prefix sum of b will always be greater than the prefix size or equal. So we can choose aj randomly. Which is less than or equal to bi, and j can be any index from on to 2n. Then increment aj by 1. So you are not allowed to skip any option. The total number of increment is exactly n. Define f of b to be the maximum possible value of mix A under the optimal sequence of increment elements. Maximum possible value. You're allowed to rearrange the element of B however you want. Then given key, your task is to find a rearrangement R of B such that f of R is equal to K. This problem is a bit tricky, I think. Size of array A is 2n, but the mix can be up to, if there are n increments, 1, 2, 3, kind of a square root complexity, the square root of n. To be precisely n into n plus 1 by 2. We can find it by doing binary search, or maybe in a shortcut mathematical way. I kind of understand this problem, but now I need to decide which problem I will choose to dive into. So it's like the solution is still 8, but what is this 100? I think I'll go with the valley problem. Number of such a permutation, so that there will be no valley of sequence of K. That means all the sequence of yes, like all the, what is the condition, what is this necessary and sufficient condition for like there will not be any sequence of elements, k minus 1 elements, such that there will be no k minus 1 element still. What is the maximum k? K is 3, you see. So it's not k minus 1 element, it will be k minus 2 element. There will not be any sequence of k minus 2 elements such that prefix left max and minimum of left max and right max is also greater than the max of all these k minus 2 elements. There should not exist any sequence of k elements such that all the other elements left of those k minus 1 elements, max element from those elements, and the right sides max elements, they must not uh, like they must not be greater than all those k-1 elements. How can we maintain that? How can we maintain that? Suffix max, prefix max. For like the third test case, 0 4 0 3 0, for this test case we said k is equal 3 for this test case, so we said that there will be no such a element sequence of elements of 1 which will satisfy the condition. So what is the possible candidate in that position? What are the possible candidates in that position? For the middle position, I think only possible candidate is 5. Why? If we keep 5 here, there will be no element in the left, no element in the right that are both will be max. There will be no such element. And also for 3 and 4 that condition hold, because the left will definitely be less than 4 and right is already greater, so that's not a problem. We need to ensure that at least one of the left or right is less than those elements. So this is the fixed kind of 3 elements. Now for these 2, there are 2 options, either put 1 2 or 2 1. That's why the answer for the third test case is 2. Yes. Answer for the third test case is 2. Now for this element, let's try this element. Try this test case. Here it's k is equal 6. So there must not exist any sequence of 4 index such that one of both of their left will be 0. Let's say we arbitrarily pick this index, and this index, and let's say 1. So we just pick this index, this index, this index, and this index. This 4 index, okay? Now there must not exist any element in the left and right such that they will both be greater than this 4 element. So if we put 6 here and 5 here, then it will definitely violate the rule. We cannot put 6 and 5 there. So what this means is that since 6 and 5 are greater than 4, 6 and 5 are greater than k minus 2,
they must maintain a distance less than uh, less than or to what? K minus 1, I think. Distance, what is the definition of distance here? Like for on 7, what is the distance between them? 1 or 2? Let's consider it's 1. So in that case, 6 and 5, what will be the distance between them? There can be at most k minus 1 element, k minus 2 element, and 1. So I think it's k minus 2. Greater, less than or equal k minus 2 distance. Yes. Right. K minus 2. Since they are greater than k minus, they must maintain distance less or equal this. So that's a necessary condition. Now we can distance less than k minus 2. Not necessarily. Like in between 6 and 5, there can be at most k minus 2 minimum elements. That's the idea, I think. There can be at most k minus 3 minimum elements. Right? There can be at most k minus 3 minimum elements. So all the elements all the pair of elements such that max of that pair is greater than k minus 2. Yeah, they must they can have at most k minus 3 minimum elements in between them. So this is the necessary condition. At most k minus 3 minimum elements in between them. Now can we like maintain this condition and construct the permutation? K minus 1. In that case, the most less pair is like on k plus 1 and k. K minus 1 and k. They must maintain a distance of k minus not the distance, like they must have they cannot have more than k minus 3 minimum elements. Then k minus 1 and k plus 1 also have the same restriction, and basically all the elements that are greater than k minus 1, and among them they must form a
form a sequence, or like form a rearrangement such that among them. Oh, okay, now I get it. Now I get it. I think. No, 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 no. They cannot have less than k minus 3 element. They cannot have more than k minus 3 elements that are less than them. I think we can just find the minimum possible element in the left, which is greater than k minus 1, greater than or equal k plus 1, minimum possible index, and by which we can put elements. When we are putting an element at position I, we first need to find, like, first need to check what is the element. Is it greater than k minus 2? Then the condition will be something else. I think there are two types of elements. One type which are greater than k minus 2, right? There are two types of elements. One types which are greater than k minus 2, and another type is which are less than or equal to k minus 2. So once we put an element, we can maintain this like a boolean, whether we the maximum element. We just need to know, whenever we are trying to put a first type of elements, we need to check all the elements that we have already placed, and less or placed in range k minus 2 to that element minus k plus 2, I think. What is the number of minimum elements we placed after them? From this condition, we can decide whether we can place this element or not.
then it's a n cube solution. The number of permutation 27 people solved it. This will almost will be 100 by the end of the contest. How many submission? 126 submission. Okay, I think this problem is not that hard. Like, we need to just come up with a solution. I'm not getting any solution idea. I understand the necessary condition, or like how we should basically create the permutations. Kind of understand or visualize the process or the condition we need to maintain, but how to find the possible permutations count maintaining this condition when we have n cube complexity? Can we solve it with dp? How can we solve it with dp? There are two types of elements. So we can keep like what is the remaining number of elements? What is the remaining number of type 1 element, type 2 elements? Maintaining one of them is enough. And then for a particular element of first type that we have already placed, right? That we have already placed, we just need to, I think, keep track of the minimum possible second type element, right? Like, second type element can be any element. So I just need to maintain the count of elements that are the second type we have placed after placing the first type element. So this is like dp of I. What does mean by I? I is like the frequency of let's say first type element that we have already placed, and whether we have placed the second type element or not. If we placed the second type element, then what is the count? What is the count of the first type element after placing a second type element? That's the idea, I think. So if let's say this is this t, if t equal to 1, then j must be less than or is equal k minus 3. Otherwise, no transition. I mean, there will be transition, otherwise or else no transition. Only if t equal 1, no transition. And there will be always a transition if t is equal to 0. We can place second type element or first type element, any one of them we want. So will this dp approach actually work? I think it will work. What is the complexity? Because I think their expected complexity in n cube, and here it is. It seems like n square. Yeah, I think it's like n square. But I feel like the DP idea should work. Yeah. So I'll just do it. Let's just do it. N K T N. The first Q and K, and then N, and then K, and the elements of AI. I think we'll use global and modular arithmetic. Is modular. Don't need the NCR NPR, and also I think I do not need inverse and division. Also power, and our mod is this. So constant and n can be up to 500 in dp of n, n to nn, and array, right? We can just max max we can put max possible, or like what should be the name of this variable name? I think I'll just make it max. So max will be, let's say keep it k. T01. So dp of I tj will be -1. Go off. We start when we placed 0 type 2 elements. I think we do not need the middle t as well, I think, because we can always can we, if we just change the definition, like if we just change the definition of placing, I think I'll just change this, like how many first type we placed, how many second type we placed, and what is the number of elements in the middle of them. Since that's the case, it will be n cube. T is equal to 0. Yeah, this is necessary, because if we just maintain 2 type, like whether we place type 2 type 1 or not, so far that is not enough. That is not enough. That's why we need 3 dimension, and that's why it is n cube. Now it's feel like we are going in the right direction. So type on we placed, how many type on we placed, how many type 2 we placed, and the count. If type on plus type 2 equal n, and we didn't take the value n, cn and comma k. So return c must be less than or equal k minus 3, then or otherwise return 0. Or we can just simply like do this, return 1, and do some pruning, like if c is greater than k minus 3, then return 0, because we going forward doesn't make any sense. we try to put like the first option place the type on operation, type 1 elements, place the type on elements, so return is equal to 0. And if we place the type on, when we can place the type on, if type 1 elements we have placed that are less than, how many type on elements we have? There are k minus 2, right? Like 1, like k is equal let's say 4, so the type on elements are only in the middle elements that are 1 and 2, so 1 and 2, so that must be k minus 2. Then we can place one of them. So self add rate go of t1 plus 1, then t2. Now c will get increased, we'll keep nc is equal to c if t2 is less than n minus k plus 2, like the remaining element, right? There's 6 and minus 4 remaining elements, and t2 is greater than 0, then nc plus is equal to 1 nc. So I think this is the condition for placing on one of the type on elements. Now what is the condition for type 2 elements? If t2 is less than n minus k plus 2, then we can only place this. In that case, self add will be red comma go of t1 t2 plus 1, and will the c will change? I think they will not. Return dp of t1 t2 of c equal red, and we will check the cache check. C is not 0 minus 1, dp of t1 comma t2 and c. Let's see. 552140 not working. Oh, because we didn't check, like shit. Look, we didn't ever use the array a. Then this just changes. The definition now changes. This is the index so far we have considered, and t2 means how many type 2 element we have already processed or placed. Now if I equal n, I'll say return 1, because we already do the pruning if c is greater than k minus 3, then return 0. If dp of I type 2 elements we have placed so far, and see if they are not equal minus 1, return dp of I of t2 and c, and the rate is 0. Now we will check, can we place a type on element? t1 is equal I element we have already placed plus t2 element we have already placed. So like how many this many ion elements we have already placed. This is t1. So if t1 is less than k minus 2, then we can place type on elements, and nc will be c if t1 is greater than, t2 is greater than 0 and t2 is less than n minus k minus 2 plus 2, then nc plus equal 1, self add go of I plus 1, T2 and NC. Now we'll check what is the condition for T2 elements we can place. Like it must be less than equal to this and self add red and go of I plus 1 comma T2 plus 1 comma C. Return dp of I of T2 of C. Again there is a mistake. Because we will put, consider this if a of I equal 0. Otherwise, which element we will place right now is just fixed, right? So if a of I is greater than k minus 3, sorry, k minus 2, I think greater or equal k minus 2? Greater or equal k minus 2. For example, k is equal to 4, then 3, k minus 2 is 2. No, greater than k minus 2. Then it's a type 2 element. So for type 2 element, it is nothing like go of I plus 1, type 2 plus 1, and C will never change. Otherwise, it's a type 1 element, so we'll just do the same thing. If T2 is greater than 0 and T2 is less than n minus k plus 2 and nc plus equal 1, so self add go of I plus 1 comma type 2 and nc. But it should be equal to red. Didn't work. What is the time? Remaining time 6 minutes. If C is greater than k minus 3, k minus 3 is the number of elements in the middle we can place, then we should return 0. If we persist all the elements, that's a possible permutation. Oh bro, there is a problem. Like, how many ways to place a element at this position? I think there are also will need to do some multiplication operation, because there are ways. How many ways are there? We're placing T1. How many T2 are there? Like T k minus 2 minus T1. This many T1 are out there. These are the possible option we have. Then here is n minus k plus 2 minus T2. And there is only one option. 20. I think I'm close. Why there is only one option? Yeah, because the element is fixed here. Let me just check the condition we have. If I comma T2C, if a of I is equal to 0, then we will place a random. There is a mistake as well. Like this suffix what? Suffix type 2 and suffix type 1 element. Shit. Suff T1 and suff T2n. So if a of I is not equal to 0, if a of I is greater than k minus 2, then this is a type 2 operation, so suff T2 of I is equal to 1, else suff T1 of I is equal to 1. So we'll do the prefix sum. Suff T1 of I plus equals suff T1 of I plus 1. So suff T2 of I plus equals suff T2 of I plus 1.
this also will be decreased by sub t1 of I. So this is t2 sub t1 of I. I think I'm very close. What are the mistakes? Is this plus? No, wait. Let's just check the conditions. T1 is equal I minus t2. How many elements? K minus 2 elements. If T1 is less than or equal K minus 2 means that we didn't place all those elements. So if T2 is greater than 0, that means we have already placed a type 2 elements, and type 2 elements will also place the type 2 element, because K minus n minus K minus 2, all the elements that are type 2, I think there is a minus 1. Yeah. N minus K plus 2. So if K is equal 4, N is equal, let's say 6, then 6 minus 4 plus 2. It's like 6 minus 2 is 4. Second plus 3, 4, 5, 6. Yeah, it's true. Then NC plus is equal 1. Self-factored mul of I plus 1. Type 2 elements we have already placed. New C, and the number of possible ways to place one element right here. So this is K minus 2 minus T1. What does it mean? That means K minus 2 elements are the total number of type 1 elements we will place. T1 is already we have placed, and sum of 1 of T of I, that means number of elements that we will, that are fixed. That are fixed. So if this is greater than 0, only we do this. If this is shit, 26, 3 and 44 second. That are the total elements T2 we have already placed, that are fixed elements. So other than 12 elements are, yeah. Shit. Type C is this. What is the mistake? Shit, I think I'm very close. Okay, the contest is over. And how many people are able to solve it? 34. Shit. very close. What is the mistake? Zero, and count is also 0. If the middle count is greater than k minus 3, so we return 0. Oh shit, why it is plus 1? Okay, but still wrong. But why I